Yo, 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 here we are looking at 3.4 and 3.5, where we're going to be looking at finding the vertex, which is in turn is finding the max or minimum value of a parabola. And that depends on the a value. So if the a is negative, we know we have a frowny face, and we know we're going to have a maximum y value. And if the a is positive, then we know we're going to have a smiley face, and that way we know we'll have a minimum value. So in doing that, we use part of the quadratic formula, negative b over 2a. This will give us our h value of the vertex. And then when we plug that value into the function, and we get our k value or our y value of that function. So if this particular one, first we're more concerned about our b value, which is 1. So we put the minus there because of the formula. And then our a is negative 2. And bada boom, math happens. We find out that our h value is 1/4. Then we plug in 1/4 into our function. We evaluate, and we get negative 39 over 8. So you have to look here. Sometimes it asks for a decimal. Sometimes it asks for a fraction. And so the more handy you get with your calculator, you can be able to do this with your calculator. Or here, some of you might have some difficulty with fractions. And as I change 1/4 to something over 8, that work is here, as well as changing 5 to something over 8. Next problem would be the same process. All right, so we'll look at our b value, which was negative 16, so it becomes positive 16. Our a value is 4, so we end up getting a whole number here. That is our h. We plug it in to find our k. Voila. Here we're using the quadratic formula that we use in the last section here. So first things first, we need to move that 2 over so it becomes negative 2 for our c. We plug in our a, b, and our c values and evaluate to give us 1 and negative 2/3. Here we have a parabola given it to us. It's the trajectory of a ball that is moving, a baseball more specifically. And how high is it after 1 second? So that simply means plug in 1 into the given function. So I plug in 1, evaluate, I get 30. And the next one is saying is find the maximum height. So this is what we did in number 1 and number 2 using negative b over 2a. So we do that. My b value is 26 and my a value is negative 2. That ends up being 13 halves is what I'm going to have to plug in. So it tells us that we need a decimal for an answer. So you could have used 6.5 here if you wanted to and evaluated it. There's lots of different ways to use this with your calculator. If you need to know how to do that, by all means ask. So just run through and get 90.5. So if it had asked for a fraction, I would have had to put 181 over 2. Since it asked for a decimal, then I simply put in 90.5. Here we're going to have to use the Pythagorean theorem, a squared plus b squared equals c squared, of the given information. So here's my a, my b, and my c. I just simply evaluate, simplify. I ended up being able to factor here. And since we're talking about distance here, we can't have a negative distance. Humans don't understand what negative distance means. So we know our answer is 120 feet. We also could use the quadratic formula, or we could use your graphing calculator. Here we're talking about local maximum and local minimum, as well as absolute. Absolute means exactly what it is. It's absolutely the highest or lowest. So in this particular example, we do have something that is the highest. So this here, it is considered a local maximum because we do have a hill here. We do have a valley here. This would also be a local because since this goes on forever down, it does not have an absolute minimum, but it does have a local minimum. And when we're looking at these values, we're looking at the y value. And so here, since there is no other point that is higher than this one, this is also considered an absolute maximum. So this point can have the label as a local and absolute maximum. So we look over here. So actually all of these points here are considered local maximum, D and B. And then here this is considered a local minimum, Q. And then we look at absolute value, or absolute maximum. And since there's no point higher than this, B is that. And the next one we're looking at end behavior, and it's an easy way to see what is going to be happening with a graph just by looking at the leading exponent. So this has to be the highest exponent in the function, as well as that coefficient if it's positive or negative. So if we have an odd exponent, so this could be 3, 5, 7, and so on, it's either going to have this particular shape on the ends. So on the far left, it would be going down, and the far right, it would be going up. And that is when our coefficient is positive. When our coefficient is negative, then there's this alternate. On the left-hand side, it will be going up and going down on the right side. When we have even exponents, so this would be 2, 4, 6, 8, etc., then we are also going to be looking at the coefficient, whether it's positive or negative. If it's positive, both will be going up and both will be going down if it is negative. And so we have some examples of that. So we're only looking at what is highlighted. Everything after that is insignificant. And so I don't care that this is a pi, I just care that it's positive. Here I got positive. I don't care if it's a decimal. I just care that that is positive. Here they try to trick you here. We need the highest one, so it is positive. Even. And then we have a negative here. And then here, I don't care what this whole number is. I just care that it is even and that this is positive in the front. Here, I don't care about how large the number is. I just care that it is odd and it is negative to have this shape. Here, we're given a graph, so I'm just looking at the end behavior. We can see it's this. Therefore, I know it's odd. And then since it's doing in this fashion, I know that it's also negative. So I just picked the one that matches that. Here, we can put this into our graphic calculator if you wanted to. We could graph it by hand. Or I just simply look at this and I have an odd exponent as well as a positive coefficient. So I know it has to have this type of behavior. And this next one is asking for zeros. Zeros are nothing more about when the graph crosses the x-axis. And so here, I know that I have one real zero. Here, I'm looking for positive real zeros. If I look at the function, I can see that I have 3 zeros, but only 2 of them are positive.